So how does this process help us solve this example that we got that you didn't know how to integrate yet? Well, I'll show you. So the key here is that u is a function that you want to differentiate. So u is a function you want to differentiate. So it's going to get easier if I differentiate it. V is a function that you don't mind anti-differentiating. So that is, we're going to pick our u and v based on something that if I differentiate it, it's going to get simpler. So I want to differentiate it. And v is going to be something that if I anti-differentiate it, it doesn't get any harder. So I don't mind anti-differentiating it. Well, I don't mind anti-differentiating sine because that's just going to be negative cosine. It's not any more complicated than the sine that I started with. So that's going to be the dv. All right, and then something I want to differentiate, well, I want to differentiate this one, x, because the derivative of x is just 1, so it will get much simpler. So that's what I'm going to use as my u and my dv. All right, and then I'm going to say that that equals, so our formula here is the integral of u dv equals uv minus the integral of v du. So the integral of u dv equals uv minus the integral of v du. And you'll get very much used to writing that. I was going to write that down here smaller, and I failed to do so. All right, so here's what you do. But I guess we need to write out sort of a little chart first. So I'll show you how we're going to do this. I'm going to skip down here. So integral x sine x dx. So once we identify that this is going to be u and this is going to be dv. Now people lay this out different ways, but I'm going to lay my chart out like this. I like to go u du v dv. All right, and we're going to pick what all these things are, and you're going to also remember that your du and your dv always have a dx in them because they're derivatives. All right, so what did I pick u to be? I picked it to be x. What did I pick my dv to be? So dv is down here. I picked it to be sine x dx. Sine x dx. All right, and then what I do is I differentiate this one, and I integrate this one. Right, so the antiderivative of sine x is negative cosine x. I'll try to write this nicer next time. The derivative of x is 1. So now I know what the v du is going to be the v du. All right, so my integral of x sine x dx equals, it's uv minus the integral of v du. So u is x. V is negative cosine x minus the integral of v is negative cosine x, and du is 1 dx. So I can just put dx. All right. So then you can sort of see how this is going to be easier to do. So this integral x sine x dx equals negative x cosine x plus the integral of cosine x dx. So I've changed my integral for something I don't know how to do to something I do know how to do. I know the antiderivative of cosine x is negative sine x, so this equals negative cosine x minus sine x. Now once I've completed the final integral is where I put the plus c. I don't need to put a plus c here because I still have an integral that contains a plus c. So when I do the final integral, I do my plus c. All right, looks like we can squeeze in maybe one more here. So let's try, we're going to do Rogowski, page 403, and we're going to do number 8. So this is posted. So Rogowski 403, number 8. So I have integral of 2x plus 1 e to the x dx. All right, what do I want to do a derivative of? I want to do the derivative of 2x plus 1. So that's going to be my u. What do I not mind integrating? I don't mind integrating e to the x dx, so that's going to be my dx. So then I lay out my chart with my u, du, v, dv. That should have been a dv there, sorry, dv. All right. And then, so dv is e to the x dx. So I'm filling in these corners first. U is 2x plus 1. All right. The dv has the dx on it. Carries the dx. All right, then this derivative is 2 dx. this antiderivative is just e to the x. I don't need to put a plus c because it's going into an integral that has its own plus c. All right, so then I can say that this integral of 2x plus 1, I'll just rewrite it down here since I sort of broke the flow from up there. I want to say that it equals uv plus the integral of v du. U is 2x plus 1. V is e to the x plus the integral of v du. So it's e to the x times 2 dx. So I'm going to put that as 2 e to the x dx. All right, so that equals 2x plus 1 e to the x. And I can factor out the 2 because now it's just a constant, plus 2 e to the x dx. And I know the antiderivative of e to the x is e to the x. So I have 2x plus 1 e to the x plus 2 e to the x. If you want, that equals 2x e to the x plus 3 e to the x. Plus c goes here, and that's that antiderivative. So there you go. There's a basic integration by parts. And if you get that, you really get the whole thing. But we're going to do a ton more examples.